Good evening and welcome to what can only be described as the Madhouse, but I have to be sensible today because I have one of the MDs, in fact the MD of Laserworld himself. It's Norbert, and he is going to demonstrate, show and give you the ins and outs of lasers. Right, so it's question and answer, so if you've got a question we will try and answer it. We can't sort of delve into the conversation straight away, so we're going to try and do our best to look and see what's going on, but also at the same time Norbert will be showing you some lasers. Now we've got some relatively cheap and cheerful lasers up to, what's the most expensive one you've got here today, Norbert?
I've got the Tom 2 with me here, which is the most expensive but relatively expensive. It's quite affordable still, laser here, but this is basically the DJ range, the range we're covering especially for DJs and smaller nightclubs. This is what we're talking about. So from the consumer level to the DJ level, we don't do the high-end stuff, right? Because this is probably kind of too complicated, and probably it's a bit different in general.
Sure. Okay. Well, I think what we'll do, I think it's the best thing is if we or Norbert goes through some of the lasers, the ins and outs, shows you the internal workings, and then after we've done that, if we then say send us your questions, and then we can do the question and answer.
Yes, basically you can already send your questions. We try to follow the question stream. There's already people popping in. I see it's pretty good. Let's just start with having an inside look into a laser, how a laser works, how it's built in general, and I try to start with a let's say a normal laser, a laser that everybody can afford. I think the CS1000, it's kind of a standard standard system nowadays.
Let's move the camera and we can take a closer look.
Exactly, move the camera.
Okay, so
let's have a look inside. This is the CS1000. I already prepared it. Opened the lid. We have a look inside the unit.
Can people let me? Is the camera okay, or is it a little bit blurred, or is it good quality? So if you could just let me know. I'm sure they will. Someone should say if it's.
Someone should say it.
Yeah. Hi guys.
Okay. So let's have a look at the interior of this CS1000 laser and see what's basically inside. All the lasers are more or less built the same way, so it's kind of similar how the lasers are built. And the idea of the laser is to create white light out of this. This unit is a white light RGB system, so you cannot only have one color like in the old days with lasers, where lasers were very limited. But this one is a full color laser. It's a white light RGB, so it can do different colors. This one can do up to 7 colors.
Right.
It's even a bit more, but basically 7 colors. So what can we see in here? We see the different laser sources, which is the most important part of the laser. Let's just get this camera down as well, because we've got different cameras here today to show the different on different channels. And this one, now you can see that as well here. What we can see here is we have the different laser sources. We have 1, 2, 3 different laser sources. This one is an RGB laser, as I said. So we have red, green and blue laser sources inside here. These 3 colors mix up together to create a white light laser output. So it's important we don't have a white laser source inside here. This is technically not possible. There is technical reasons why this is not done, at least not at that price level. So here we have the mixture of the 3 colors, and this mixture happens optically. So we have different optics in here. You can see that here at the front. I just turn it that way. So we have different optics here. This one is a normal deflection mirror, so the beam comes out here and is deflected that direction. Then we have another beam that comes in here and is deflected the same direction. This one as well. So it adds up to a white beam here. The specialty about these mirrors, these are so-called dichroic filters, which means they let pass certain wavelengths and they deflect certain wavelengths. So these are specific for that color, and this one is specific for that color. So it's a very, very special mixture. Many of you probably know the white LEDs you have. You have RGB, W LED systems now in the market, and this is a completely different thing. So it works completely differently than a laser. So this makes the laser also quite special and quite different to normal LED lighting. Because many people ask me and say, hey, why is a laser so expensive? And I say, hey, it's not expensive anymore, because all this technology became very, very affordable, because it's standardized. They used to be very expensive, yeah. But it's still very different to LED lighting. And LEDs can be manufactured very cheaply, and you have all the components. Everything is pretty decent made together. You have a huge market, but with a laser, it's very different, and this one of the difficult parts is the optical thing. So we have the optical part. Then the white beam we created here, it hits the scanners, the scanner mirrors. You see the scanner mirrors here. I'm just moving them a bit so you can see them reflecting here. There is a X and Y axis scanner, so the beam hits these scanners and they're moving pretty fast, so it's a mechanical deflection. It's not like with an old TV. Probably some of you know old TVs with the big screen, the very, very heavy units. There the deflection of the electrons was done electronically, so it was not a mechanical deflection. Mechanical always means it's kind of limited. It's kind of, you have inertia, the problem of inertia. That's why the bigger the scanner mirrors are, the higher the inertia, the less fast they move. And the more flickering the image gets.
Got a question here from Donald Slayromph, I think I've got that correctly. What happens if you shine white light from this laser through one of those scientific light prism things? I would expect it to diffuse back to its original colours, which would be red, green and blue. Actually, that's quite a good question.
That's a good question. And
very good question.
Yes, you're right. That's exactly what would happen. So if you shoot this white beam into a prism, it splits up. Probably some of you know these images where a rainbow comes out of a white light beam, and this is exactly what happens. So
great question there. Good question.
Really good question. Didn't expect that early this evening. So a really good question, and this is exactly what happens. So we give the 3 wavelengths in. And it splits up to these 3 wavelengths afterwards. Okay,
here's a question for you that I'm sure people probably wouldn't have thought about but would like the answer to. Why is it then that, for example, in a laser which is RGB, you would have, let's say, for example, one of the diodes would be 200 milliwatts, the other one would be 700 milliwatts, and the other one, for example, would be 400 milliwatts? Why aren't they all 300 milliwatts, or why aren't they all 200?
It all depends on what you want to do with a laser. So there's different power levels of the lasers and of the different laser sources. There is a limitation in the different power levels to a certain extent per source. I will get into detail later on, because this is a very detailed topic we can talk about, and probably people can learn more about optics and optical combination. This is what will happen in let's say in about 20 minutes we will talk about that, because it's a very detailed topic. Okay. But in general, what we have, if you have a laser like this one, the CS1000 RGB, it's said to have maximum power of 1 watt, 1 watt power output. But this is an addition of the different laser sources inside. So we have different power levels per source, and they add up to the 1 watt. That's exactly what's happening for the product models. Do we have a specific question here, or shall I continue with a general?
We do have one that's a little bit silly, which was something like, hold on, where is it? No, I think they've actually taken that question off, which is, oh no, here we go. Hi both, can you attach these lasers to sharks? Matthew James, I can answer that one.
That's a question for you, basically.
You can, if you have a laser that is A, waterproof, and B, battery powered. So to answer your question, yes, you can attach a laser to a shark, but I wouldn't advise it, because you've got to physically attach the laser to a shark, and it's highly likely you're going to get your head bitten off. There's your answer.
But that would be a good video for YouTube, just doing that. And I recommend if you really want to attach a laser to a shark, you should do a waterproof one. And I have one here, for example, the Garden Star. This is a laser that does some nice effects, and I think the sharks would like it too. Yeah, like the cats do.
And they're IP rated 6.7.
54, so right. Waterproof, and you can battery power them. So 12 volts, you can attach a battery pack to it, and then you can hook it up to the shark, and then
there's your answer. So silly question, but we've given you an answer.
Yeah,
sorted.
We got a solution for that.
We've got a solution. Yeah,
even for the shark guys.
Yeah, crazy.
Good. Okay. Shall we have a closer look at the laser still?
Yes.
Yeah? Okay. Let's have a look. Just getting everybody and tune. Okay, so what we've talked about is the laser sources, the optical beam path, the scanning, the beam deflection, and we will find an answer for that. There's different answers for that, so let's just wait. We get the technical part first. So each of these laser sources has a laser driver, that is responsible for getting the exact power amount for the laser source, and each driver is adjusted for each source, so you cannot just exchange them and just exchange the laser source itself. You always have to exchange the driver as well, because it needs to be adjusted for the laser source. And all this comes down to a main control board where the control features are on, especially here with this laser, as this is the CS1000 with many features, especially also for mobile DJs and mobile use. And what you can see here is we have the DMX control in here. So this one also has intelligence in the unit. What does intelligence mean for lasers? We will deal with that topic later, because intelligence has to do with DMX, has to do with ILDA, and this is something we'll talk about more in detail later. This one also has ILDA control, which is for computer control. This allows for more detailed control of what the laser actually does. You can do own texts, own logos, and we have several safety features here. We have safety feature key switch, we've got safety feature interlock connector, and we have a beam block safety we can switch here, which are safety features, and we're talking about that later, because this is an important thing. And questions came in regarding safety features, what's actually required, what the problems are. Oh, I'm sorry. Now we have an issue. Now we have an issue. Okay, no issue anymore. My mobile phone just dropped.
Okay, are you able to answer? There's just a couple more questions.
I just got an important question here from Joost.
Yeah.
Getting the thumbs up for you. He asked if I can put the thumb up for him, and that's the Joost thumb.
Okay.
Okay, continuing here. What do we have in general here? We have the dip switches for the DMX control, where we can do the settings for the DMX, and we have sensitivity for the microphone, because this one has also built-in audio controls or sound to light features. So it's not only a laser for full control, but also for automatic operation. So this is what the features are in here. So it's many features. It's not all built in here on the top level, but more of the electronics is on the lower level.
Okay, well, one here, Gareth is saying the difference between laser white light and the sun. Sun is made of many frequencies, so white light would go through prism to make all the colours of the rainbow broadband, while laser produce white light from only 3 primary colours, therefore only 3 will come out of the prism, which...
Yes.
Also, is there a time limit that lasers can be running for, or do they need to cool down for a period? That's coming from Mark.
Okay, the modern lasers, we now have the solid state laser technology. Normally is not limited to any, don't have any cool down phase anymore. It used to be in the past, especially if you had problems with cooling with gas lasers, for example. Sometimes this happened, and with the early state solid state or early state diode pumped solutions, this was a thing, but nowadays it's not necessary anymore. In some manuals it's still written, but it's actually not necessary anymore.
Okay, another one here from Michael. how come with colour red in lasers that fades before other colours?
Yeah, the fading. You mean the fading? If you just make a kind of a color fading.
I think maybe the aging. Let me just move.
You mean the aging?
Yeah, maybe the aging. Because he said, yeah, I think by the sounds of the question, it's almost as though as a laser RGB gets older, how come maybe the red diode starts to fade quicker than the other colours, maybe?
Yeah, this is not normal. Normally, it's not the red color. Especially older lasers,
right.
With DPSS green, for example, they used to they normally have this aging of the laser source. So especially the green ones, DPSS green is very common in the low end product. So really affordable laser systems, which are mainly for entertainers, mobile DJs. Many of those have still the DPSS technology inside,
right?
Which is very good. It was basically the start of the affordable lasers, but it has some cons, and one of the cons is that it's aging.
Yeah, okay.
But I mean, with the red one, it can still be. There is also red DPSS out there in the market, and there's also cheap, very very cheaply built DPSS, red diodes out there that can age as well.
Yeah.
But it's a different aging than you normally have, so it's very rare. More common is aging in the green.
Okay.
In the old green technology.
A couple of things I'll say. One is. Norbert mentioned about, you could just turn the laser on and leave it on all night. But if you think about it, a laser light is very different to a normal LED or DJ light. I would recommend a laser light shouldn't be on all night. You should just have it on for, say, half an hour, 20 minutes at a time. Because if anything, one, the laser is going to last longer. And two, you will get more of an effect. If you have the laser on all night, people are going to get bored of it. But if you turn it on periodically, then it's going to be more of a feature. Also, very quickly as well, is with a lot of the low-end lasers, the fan, the cooling system on the laser, the fan will either pull or push air inside the housing. Now, of course, whether it pulls or pushes, that's going to cause a lot of ambient dust just to flow in and out of the laser. So over time, that dust is going to land on the mirrors, which in turn could make the laser look as though it's dimming. So it's probably a good idea.
That's a good question. Yeah, that's exactly. Maybe that's also one point. We will have a look at the maintenance of a laser later on, so you can learn a bit about how to maintain the laser, what needs to be done, and what shouldn't be done.
Good.
But one thing to just add what you just stated, just to switch it on and off. This is one type of laser application. So what you're mentioning is the typical mobile DJ application where you just make ambient beams, audience beams, something like that. Yeah. But there is another type of laser application, which is the projection type of laser application, meaning you do architectural projections, you do logo projections, and something like that. And of course, then you don't switch it off. Right, so you have it running continuously, and probably even run it at full power. And this, of course, can be a challenge to heat management in a laser system, and there are laser systems out in the market that cannot handle it. I know of some of them. Instead, of course, we're checking our systems to, of course, be able to handle such a situation. But there is, some box moving products out there that probably cannot do that. So it always needs to be checked. But in general, there is no problem with the heat management.
From Holland.
Joost, yeah.
Joost, sorry. Hello. Yeah. Sorry. So at the moment we've got two cameras on because Norbert is streaming for Laserworld, is that right?
Yes, exactly. We're streaming live on the Laserworld website.
And then also from my channel on Facebook. So there you go. Alright, cool. I'll just have another quick look, see if there's any more like Club Laser on site. Tell me about the best placement in the room. Can it be eye level correct? Right, Gene. I know Gene Raphael from America. Right, now, I know a little bit about this, and I did have my wrist slapped a while ago. A laser should be 3 meters minimum height from ground level. So really, if you think about it, it doesn't matter whether the laser... Well, I suppose it does. If it's a really low-powered laser, And the way to look at that, if you imagine the likes of the garden laser we've got here, you've got, let's say, a green diode hitting a diffraction mirror that splits that up into, say, 200 beams. Then that milliwatt from the laser, whether it be 10, 20 or 100, is going to be split up. So that isn't so bad. But then when you have, let's say, for example, the CS1000, and let's imagine you have that scanning the crowd, and all of a sudden you've got 1 watt of a pinprick of a laser light, and that, let's say, hits someone's eye for a millisecond, potentially, not definitely, but potentially that could damage the person's eye. So really what you need to do is make sure that when you set up the lasers, that as well as being 3 meters above the crowd, that the actual laser beams don't hit the crowd. But there is a but there, which I'm sure Norbert will explain. There's a lot of software out there now that will, you almost got like a square. And in the software, you can set a level of laser light according to where the laser will scan. So, for example, you can by all means scan the crowd, but as soon as the laser dips below a certain level, the laser intensity will reduce, which is adequate for it to scan the crowd. And then when it's above that certain level, then it can go to full capacity. Does that make sense? Yeah.
Yes, definitely,
Okay.
definitely. That's one of the features of the common software in the market.
Mm-hmm.
So, but what I just to add, the 3 meter level is pretty correct.
Yeah.
Except Germany, you have 2.7 meters, so it's lower allowed.
Okay. Is that because
this
you're
only-
shorter than us?
Yeah, most probably. Yeah. No, the thing is basically you have to respect the legal level in the crowd, which is class 2, level class 2, which means 1 milliwatt power. Mm-hmm. 1 milliwatt power is not much, so this is meant for eye-safe laser operation in the crowd.
Right.
So this needs to be respected. This is all written down in the IEC 682025, which is the international regulation. Mm-hmm. And applies for laser safety in general.
Right.
So there is a lot of regulated. We will see something about that later on with the interlock, with the key switch and something like that. It's all written down there. But the general thing is to just respect this level. So this is the target. So it's of course possible under certain circumstances to have the laser lower than 3 meter.
Yeah.
But then you have the certain distance to the audience, and nobody must be able to access the laser and access the laser safety area.
Yeah.
So there is something about that. In general, the most common thing is to use the software to reduce laser power in the audience area if you do audience scanning. Talking about audience scanning, except the US at the moment, because in the US there's different regulations. They're kind of, they're not only they not only have the international IEC regulation, they have additional regulations. They have a lot of paperwork regulations, which don't make it that easy. Mm-hmm. So I don't want to go to that specific topic, but more look at the general things that are all over Europe that apply to the rest of the world except the US.
Got a quick question here from Keith Sears. Motty, how you doing, my friend? At the last BPM, he asked if there was a laser that could write in Bulgarian and was told no. Now, I would have thought that, like the green text laser, unless in Bulgaria you've got certain different numerals and letters, I would have thought just a normal QWERTY keyboard would do, wouldn't it?
If you have a proper software, it depends on the software. If you do text like that, it's normally not done with a normal key text laser. You just have in mind where you have the keyboard. This is just for normal text, for English, for normal text. If you want to do text with a proper software, you're basically not limited at all.
Right.
So most of the softwares can just use TTF fonts you normally can use with Word or Excel, and it's no problem to use them because you just use your keyboard and your keyboard settings on the computer, and then it takes the language you're writing in.
So really, to answer you, Keith, number one, you need a relatively decent laser that can produce text.
Yes.
Number two, you need software, and number three, it's just up to you to write the text.
Yes,
End of.
exactly.
There you go. So, Keith, it can be done.
There's a question from Joost here.
I love the avatar laser. Hold on.
Yeah, I wrote, yeah. I love the Avatar Laser Command Center, old system. It's a nice idea for Laserworld to create something like this, a nice OEM laser controller that works simple without a PC. Yeah, basically there is options for for laser control without the PC, but basically the idea is always to have full control. Many of the lasers nowadays have the at least the basic level ones have DMX control, but there's also additional features that can use DMX as control option. And I think, from my opinion, it doesn't make sense to make a new console specific for a very small target group, but probably more go into very common control options like DMX.
Yeah.
So on the one hand, we have the option with IRLA control, which is computer control, and then we have the option with DMX. And there is new features, for example, for DMX control. I just show you one, which is the ShowNet. I'm just getting that one here. It's the ShowNet you get with a show editor software, for example.
Yeah.
And it has an SD card built in, so you can put ILDA frames on the SD card, and then just play them back with DMX. You have control over rotation, you have control over flip X, Y axis and something like that. So in my opinion, it doesn't make sense to make a separate laser controller, but make it easy for people to use the existing controller structure like DMX, which they understand, to use for laser control, because then you can combine the lighting and the laser together in one cue, for example, or in one preset, and then you can operate it much more actively and much more versatile.
Right, got you. Let's have a look. Could you mix a laser color? What I mean is have a red, green and blue laser that would look white from the center of a room, but separate color if you were looking from a different angle.
That's a different difficult thing. You could do something like that, but you need to have some some special surface to go on with the projection.
Right.
What you can do is, of course, you can have the split up of the beam with optical means, like with a garden laser, for example, like with a grating, with an optical grating. This is possible. We show that later on. We've got some here.
Yep.
So you see how you shoot in a white beam and it splits up to the colors. But but it's not depending on the viewing angle.
Yep.
It's a general thing. So the viewing angle, if you have something like that, you need to have this kind of prism effect, like it's mentioned previously. Then it would split up like that.
Okay. Should we have a demo of one of them?
You mean of the gratings?
Yeah, or one of the lasers.
One of the lasers?
I reckon. Would you like us to turn one of the lasers on?
Well, I think we should turn on the CS1000 just to show the beam path. So probably you can power on the fog machine so we can see the beams here in the laser, and I just get the software going, and just need a bit of fog. It's not much. So what you can see now, I do the key switch and the interlock connector. And he made some fog. Whoa.
Is that enough?
I think so, yeah. I think so.
That'll do.
Getting the power cord.
It's very, very technical here, by the way.
Yeah, very technical
technical.
But the laser itself is technical.
Yeah. Right, what I'm going to do now, people watching on my Facebook channel, I just got to clean the lens a little bit because I think it was a little bit dirty. So I'm just going to give that a rub. Bear with me. There you go. That's better. Nothing like a good rub. Okay. Pretty cool. In fact, yeah, if I put the camera back up here, I don't think there's any need for me to hold it.
I hope you can see what's happening here inside the laser. You can see the different colors match up. You see the different colors match up. We've got green here now. And I do something now that you shouldn't do, using a non-black tool inside the laser. This is a safety thing, for example. If you use tools with lasers, it's always important to look for laser safety. If you have a non-black tool, then it will deflect the laser beam, which is very, very, very dangerous. But in this case, I want to do that.
In other words, don't try this at home.
Don't try this at home. Now you see, this is the green beam, this is the blue beam, and this is the red beam. And they're mixing up to white in the end. Now, at the moment, this is modulated, so it's not on full power. But you see, it appears like it's just the beams coming in, but they're on and off, switching on and off pretty quickly to create the image we have at the wall. You can see that here at the wall.
Okay, let me just ask people on my Facebook channel, what you're viewing now with the laser, is the image quite good, or is it a little bit blurred? Just let me know. Hopefully it should be okay. By the looks of it, I think it should be alright. Yeah, it's all good. Thank you very much.
Great. That's good. Okay, so this is the inside of the laser, and if I, for example, now turn off, just get off the interlock connector, it's off.
Yeah, now that's important, isn't it?
The same thing about it. If I turn the key and get off the key, it's also off. So many people ask me, why do you guys put on such an interlock connector, such a thing? Or on the other units, for example, I just have a look. Yeah, we got one here. For example, such a thing. Why do you put it on? Why? It's not necessary. Nobody uses it. We just don't use it. The question is not if we want to do it. We have to do it, because the problem is that this interlock connector is required by law. It's the IEC 6825, which is the regulation that is all about how a laser has to be built, how the laser has to be classified, and what features the laser must have. And one of these features is it must have the option to connect a remote shutoff, so you can shut off the laser system in case of emergency. Mm-hmm. Many people ask, hey, why should I do that? Because I have the software, or I can just plug out the power or whatever. So this regulation comes from industrial laser use. So the regulation IEC 6825 is not about show lasers, it's about lasers in general. So it's about industrial lasers, medicinal lasers, tattoo removal lasers, cosmetic lasers, so all the types of different lasers, measurement lasers, distance lasers, whatever. There's many different types of lasers. So the regulation deals with all of them. And there is regulations that say, okay, if you have a laser class 3B or 4, you're required to have this emergency shutoff interlock connector. This, for example, is not the interlock connector itself, it's just a bridge. So you're normally required to make a shutoff button here, so an extension lead, and then you have an e-stop for shutting down the system in case of emergency. The emergency case, it makes sense, because, for example, if you've got a nightclub and there's the laser going, and there's people dancing, and suddenly somebody starts climbing the truss. Yeah, and then he gets into the laser safety zone. Yeah. So you need to be able to immediately shut off the laser. Yeah. And that's why we have this system.
Isn't that, you have to have one of those by law as well? If you're, let's say, you've got lasers in a big nightclub, or
in general, the IC 6825 and additional legislation says yes, you have to do that.
Right.
In many countries, it's not handled like that. It's not that restrictive, and in many cases, it's also handled differently. This is also for larger shows where you cannot have all these individual additional cable where you have the shut off. So normally, and this is what I also do in most cases, is just using a power shut off. So this is kind of a e-stop.
Got you.
E-stop with power. So it's just a power and
right. So
it's a 6-way, and an e-stop. This is what I use normally if I have more systems, and in most countries this is accepted. There is some countries and some some authorities that don't accept it because they say, okay, it's not as fast shutting off the laser system as with the interlock connector, because the interlock interrupts the signal that powers the laser sources immediately, and this one powers off the whole laser. So there might be some power still in the power supplies,
right?
That for example, they still power the laser for some additional
but it would be milliseconds, wouldn't it? Yeah.
So if you imagine how long it takes to press the button, then another millisecond, it's not relevant at all.
Not really, no.
But I highly recommend you have a shut-off system for the laser, even though it's required by law, so I just omitted. But it's definitely worth it, because I already had situations where people entered the dangerous area, and I personally don't want to be liable if somebody gets hurt with lasers. So basically, that's just a thing that's important.
Fair comment.
The other thing is the key switch, and the key switch, of course, this makes more sense to people on the first side. Hey, you have a key switch, so nobody can operate the laser without permission, which makes sense in general if you have the laser on your table, which doesn't make sense if you have the laser in 6 meter height on the truss, mounted on the truss, because if you've got the key switch at the back, you cannot take it away when you go, for example, to have a wee or whatever. So but this is also a requirement from the IEC 6825, and that's why we have the key switch, because you can imagine if you've got a welding machine, a laser welding machine, or a laser cutting machine, of course you must be able to shut off the system when you lose when you just walk away from the operations desk. And that's what's the idea behind the key switch. So these are the two features that all the lasers 3B and class 4 need to have.
Tell me, Norbert, what sort of prices are the lasers that you have in front of you now? For example, the CS1000, which is this, and the 3300, the DS3300.
Yeah, it depends on what pricing level you have, where you buy it, but we're covering the price range between, let's say, 350 to let's say €2,000. That's basically roughly the price range we're talking about. Having some garden lasers later on, probably have a look at the very affordable ones, about €50, probably even €30. There's some ones on sale at the moment, so even very low priced products, but that's basically the range many DJs look for. There is, of course, products in between, so we have products covering the full range from the very cheap to the very expensive ones, but these are the ones we want to concentrate on. Okay. Good. Right. Okay. So let's have a look. What questions do we have still? Are there any detailed questions? Okay, thank you, Matthew. Thank you. Yeah. Okay, so let's have a more detailed look on what's actually happening here. I explained the CS1000 with all the interior and the features at the back side. So let's have a look at another laser, more professional laser, analog modulated laser. So I just switch off the CS1000 and move on to the TORM. We've got the TORM 2 open here, which is pretty new, and it's much more professional. So it's made for professional, semi-professional, but also for professional use. It's fully analog modulated, white light, and just powering that one on, so you can see the interior and the different modules in there. So to get the power cord, so this one powering up. Good. Stuff away. Okay. You can see, I'm just getting the camera down here. Okay, it's it's a similar thing. It's a similar thing than with the CS1000. It's basically more or less the same type of how the laser works. We have the different laser sources. We've got the green source, we've got the blue source coming in, and also the red source here. Just getting the red source. It's in a different pattern.
But this, I presume, this laser is much more high end, isn't it?
Yes, it is. It is. This is basically what I just said. It's for professional use, semi-professional to professional use.
Yeah.
It's got 2.5 watts, so it's quite powerful, and you can also see it's from the white light balance. It's very, very good. This is on full power at the moment.
That is very bright, actually, exceedingly
very bright. And what you can see inside is the same way of doing the laser alignment like with the CS1000. We've got the green source, blue source, red source, adding up to white, and here we have the scanner block where the beam is deflected. What you can also see here is the scanner driver. In every laser system with scanners, you also find a scanner driver. You can identify it because it's very simple to identify. It always has the many trim pots on it, because you can adjust how the scanner behaves and how the image is projected. So this is basically the scanner driver here. You can see here, and you have the laser source drivers on here where you can adjust the different laser sources and their behavior so they modulate properly analog. So this is a fully analog modulated laser system, means that it can create 16 million different color shades. So it's not only limited to 7 colors like with a
16 million.
16 million.
Right.
Yeah.
So that's not many.
No, but it's sufficient for most applications.
I think so.
No, it's the good thing about analog modulated is that you can make color shades, fadings,
right,
and different effects. Whereas with a TTL, which is the opposite, modulated laser, you can just have on and off of the different colors. Okay. So you can imagine you have 3 colors inside, red, green, and blue, and each of these colors can have a different state on and off. Right. So you have 6 different states, plus you have all on, which means white light. So you have 7 different color shades with a TTL system, and with a full analog modulated system up to 16 million color shades.
Okay, so I have to very quickly say, I do apologise if I'm dipping in and out, but one of Norbert's sons is here, and my son, and I'm just having to check on them now and again, make sure they're alright. Let me go and check on them again.
Yeah, you're welcome. No problem. No problem. Let me just check if there's any further comments here on the Laserworld Facebook page. There is one comment here in the Tom 2. Is there 1 or 2 red lasers? There's actually more red lasers in there, and this is what we're heading for. The question means how do we get higher powers in different colors? Because the colors behave differently. It's not the same type of laser source we have. It's not the green is not the same like the red, and the red is not the same like the blue. So this makes it difficult to build higher powered lasers. So for the cheap lasers, there's many lasers out there. It's easy to build them, but as soon as it comes to higher powered laser sources, it becomes different. Because the problem is, if you have, for example, a blue laser source, one laser source can have up to 1.6, 1.8 watt of power. So it's pretty simple to put one blue laser source, and then you have really high power. With green, it's much more difficult, because in green we have 2 different laser source types, more or less, which are common. One is the DPSS laser source, which we talked about earlier. The DPSS was the initial type of laser sources when lasers became affordable. Let's say 15 years ago, 20 years ago. No, not 20, 15 years ago. But DPSS has pros and cons. The pro is that it's a very bright green. It's very good visible. The con is it's not that stable, and it can wear by time. So it's and the color fading is not that homogeneous like with a green diode. You can identify it's always 5 520 nanometers. So 520 nanometers means you've got a diode source which is semiconductor. This is the latest technology we use normally, and it's very stable, very robust, very reliable. The DPSS is always 532, so 532 nanometers, which is the DPSS. So this is where you can differentiate between the different green sources. So green sources, about 150 milliwatt per source, something like that at the moment. So you can imagine if you've got one source with 1.6, 1.8 watt blue, and then 150 milliwatt green, this doesn't match up well. So we need to make more green. How do we do more green? There is some physical limitations which are a pity, but we cannot get around them. So you can have a laser source only with two polarizations, which means polarization A and B. You can combine these two polarizations with a pole cube, which works well. So you can go up to 300 milliwatt, for example, with green. But if you want to do more, you cannot use more pole cubes because this is physically not possible. This doesn't work with optics. So if you want to do more power, you have to combine them by matching them very, very closely to each other, which is so-called knife edge combination. That means you have very small mirrors and the beams are shot very close to each other, and then they match up to become one beam in the end. And then you can have two strings with one polarization A, one polarization B, and then you can match these two strings together to one final powerful laser output. The same thing applies for red. So red also has a limitation in power. So we also have something between 150, 170, some even more powerful, but it's always limited. So also red goes a pretty big array we need to build with this knife edge combination to get higher powers. So it depends on the laser system you have, which kind of optical combination you have in there. So this means the more complicated the optical combination is, the more power you need for red and green, especially red and green. Especially red is the decisive color. The more power you need, the more expensive the system gets. Because if you want to have a really, really good knife-edged system, you really need to buy a professional unit. Because there is many units out there that are more or less well knife edged, but you can imagine what happens if one of these mirrors moves only slightly. Then everything comes out of alignment, and you cannot easily realign them, because within one module, within one knife edge combined module, it's pretty hard to align the single diodes without having proper equipment to do that. So I recommend to look for professional aligned knife edge systems if you go for professional applications, for higher powered applications, especially if you need high power red.
One very quick question. With any laser, Joe Blogs, lady buys a laser from a shop. What parts can they service, or is it best, let's say there's a fault, should anyone open a laser up, is there anything that they can do to check to see if the laser isn't working, or if it isn't working, should they just think, no, take it back, get it fixed professionally?
Yeah, there's of course several things you can do by yourself, which means basically maintenance, but also alignment.
Yeah.
There is, I got a question of some days ago where somebody asked, he dropped his DS3300, and then it wasn't white anymore. The different colors, the red, green and blue, came aside, so it was not white anymore. What could he do? And this is a pretty simple thing, because it needs just some convergence alignment. The problem is that, as you have seen in the laser, the different mirrors are very, very sensitive, very small. So if there's hard shock hitting the laser.
Maybe one might move slightly.
Yeah. Even if you drive with a car and there's many bumps, something like that, it might come out of alignment. This is due to the technology we use inside lasers.
Right.
This is doesn't have anything to do with a good laser, bad laser. This is basically the technology behind it.
So that could be very quickly one of the reasons why someone may have a laser and all of a sudden they think that one of the diodes is slightly dimmer. It's not because it's old, it could be because it's just out of alignment.
This can happen, of course. And to realign the laser, we need to get, normally, if it's just the convergence, so it's red, green and blue out of alignment, we just need to move the dichroic filters inside. You can see that? Probably you can move the camera as well.
Yep.
So we have the dichroic filters, which are the ones that deflect the laser beam.
Yeah.
These ones here, I just reduce power a bit so we can see that better. Dichroic filters, and we just need to move them to get the laser beam, the white beam, into alignment again.
Gotcha.
So these are the ones, and by doing that, just give you general information how you do that. It's a bit specific per laser system, but in general there is one thing to consider. There is one main beam, which is the last one in the chain. In this case it's green, in many cases it's green, but this is the most important thing. Do not move that one as long as it's hitting the scanner mirrors. So if the main beam here still hits the scanner mirrors, do not move it, don't touch it, but then you align the other colors on this beam. So for example, for aligning the blue color, I turn off the red and just align the blue to the green. So for aligning the beam here, I would just adjust this dichroic filter to get it onto the green beam. In this case we don't do it here. I show it with a DS3300 because it's different there, but it's the same principle. And then as soon as you have aligned the blue to the green, you turn off the blue and turn on the red, so you can align the red to the green as well.
Gotcha.
And then in the end you just turn on all colors and check what happened.
Yeah.
What you may have seen now is that I didn't power the laser full power for doing this. No. And of course this is it's highly recommended. If you open the laser, always look for your personal safety, because it's the most dangerous situation is you working at the laser. It's not that dangerous for the audience if you do a show, because you already considered laser safety when setting things up.
Yeah.
So this is the important thing. The most dangerous situation is you working at the laser, doing maintenance, doing adjustments, alignments, or even setting up the laser.
Okay.
I will explain you some dangerous situations you may face when setting up a laser. So this will happen later. But now just show you where the dangerous parts are when working at the laser itself.
Let me one quick question. If I think this is a very good question as well, even though I say it myself. If, let's say, for example, Mr. Smith goes and buys TARM 2.
Yeah.
And Mr. Smith finds there's a fault. Mr. Smith then opens up the TARM 2 to try and fix it, but can't. Because he's now opened the laser, would that void the warranty?
It's all a matter of what he does with the laser. So
Right.
I can only speak for Laserworld, actually.
Yeah.
But
you see what I mean,
In our case, it's that way. You of course have to maintain the laser. You have to clean it frequently, otherwise it might get dusty inside, and also may lead to failures.
Yes.
So for example, this laser, of course, it's dust-proof built. So this is a professional laser. You don't have that necessity of frequent cleaning, not that much, as for example with the CS1000, which is not at that level. So if you have, for example, the fog and haze fluid that comes into the laser and gets stuck in there, probably even smoke from
it's going to have to be cleaned.
It has to be cleaned, otherwise there is corrosion inside. The boards they get damaged,
and just residue from the smoke and the dust collects.
Exactly. So this is of course possible, and it's of course required to be done. So you have to open the laser to do that, but you don't have to power it on to do that. So it's recommended to not have it powered on when cleaning the laser and the optics. But of course, it's also necessary to be able to make the convergence alignment. If you just drive somewhere and it comes out of alignment, of course you need to open it, of course you need to align it, because you want to do a show. You cannot just send it back because you went just through a bumpy road. Because the same can happen if you send it to us, we do the convergence alignment, send it back to you, and the parcel driver goes over a bumpy road, and then it arrives at your place misaligned again, which is ridiculous. It happened.
But I think it's really logic. You know, if you feel there's a fault with the laser and you need to open it up to check, then don't start looking and wondering what everything does. I think if you can understand, as Norbert said, alignment and cleaning the laser, then I would personally say, as someone who knows very little, but that's probably as far as I would go.
Yeah, there is nothing more. There's nothing more to do within the laser. So if there's more faults, you normally cannot do anything.
No.
So if you see, hey, one diode is dead, you see it here, it's not lighting up, there is nothing, it's not coming out, one diode is dead. You don't know if the diode is dead, if the driver is dead, if the main control board is dead, or anything else is dead, you know, some power supply unit. There's many things that can be dead.
Yeah.
There is, of course, if you're skilled electrician, you can just do measurements and stuff like that. But normal users cannot do more than that. So if you see, hey, there is one diode, it's not lighting up anymore, one of the scanners is not moving, it's only X axis or Y axis moving, but the other one not anymore, then of course there's nothing more you can do. You just call the service, and people probably give you further advice what to do, what to check, or they just ask you sending it back. But that's a different thing. What I would like to have a look at now is safety precautions when opening the laser and working at the laser.
Yep.
Especially if it's lit up, like now, where we do alignments. So if you have this laser opened, of course, when I open it, it's switched off during opening it, and it's also powered off before opening it.
Yeah.
Why? If it's powered on, and I open the lid, and the lid is metal sheet, and I just accidentally drop the lid, and it hits some contacts here, it may, best case, only harm the laser, and the laser gets damaged, but worst case, you also get damaged because you hit the power.
And you may end up with curly hair.
Yeah, something like that. So might be funny.
I could end up with curly hair.
No, you can't. No, not at all.
Damn, it's gone.
Oh yeah.
Where the hell did my hair go?
So this is basically the thing. Then when you've got opened it, you power it on, but you only power it on slightly, not much. Just that you can see the laser output, that you can work at it, that you can adjust it. But you don't need full power output. You don't need it. It's simply not necessary. And of course you make a projection of a pattern, normally not a single beam at first, because single beam is always dangerous, especially if you have a high powered unit like that one. It's 2.5 watt, and you can light a cigarette at 0.4 watt.
Jeez.
So 400 milliwatt is sufficient for a single beam to light a cigarette. So you can imagine what happens with 2.5 watt if you point that towards, even if it's B1 molten cloth, even if you point it there, it will start burning.
Wow.
That's a thing. You need to consider that.
That's
so
crazy.
If you make adjustments, always do patterns, try to not focus the beams, just to make sure everything is safe and sound. So now we powered this one on, we got the beam out, we see what's happening, and what many people do is they just bend over the unit to have a better look inside. No, don't do that, because I just get that one.
Just very quickly, quick question here before it disappears. Diode pumped solid state laser versus diode versus C-mount. That's what he's got here. Does that make any sense to you?
It makes sense to me.
And that's from Gareth Bannister.
Yeah, let's go. Let's do that in between before we go to the more details.
Yeah.
Diode pumped solid state laser is the DPSS. This is the basically the green ones. There's different colors were in the past, but basically it's the green laser sources that are used more in the very affordable units. Yeah. But also in the very top end powered single green units also. Right. But that's a different quality level. Okay. But those are a different way of doing laser light. In the diode pumped solid state laser, the laser light is created from a solid state solid state crystal. So there is a crystal inside, and the crystal is responsible for creating the laser light.
Okay.
In contrast, for example, to a gas laser system, where the gas was responsible for creating the laser light. So depending on the gas, the color of the laser light was different.
Right.
Same with a solid state laser. First laser, for example, was a rubin laser, which was also solid state, but it was kind of a rubin inside there.
So that's where the term solid state comes from then?
Exactly.
Right.
There's a solid state inside there, and that's what the color is coming from. So it depends on what solid state material you have in there, and there's a different color coming from.
You learn something new every day?
Yeah,
I've learned something today. Yeah, great.
And there were different colors in the past. For example, blue, 473 nanometers. Blue was DPSS blue. There was also red DPSS, but those were not that stable and reliable as the green ones, so they have disappeared now. So people don't use it anymore. Everybody uses now, especially in the professional range, use diode. Diode means it's semiconductor. The technology is similar to normal LEDs. So normal LEDs you have two different energy levels and different semiconductor levels, and coming from one level to the other level, there is a energy level loss. And you cannot lose energy in physics, so the energy needs to be transformed to a different state, and this is where the photons are emitted. So it's a pushing from one level to the other level.
So we're very technical here as well.
Technical.
We are very technical.
And then by pushing that electronically, these photons are shot out. And that's why, by the way, the LEDs are normally very focused. You don't have an LED that can make a circular emission. Probably some of you have already ask themselves, why can't you do a circular emission like with a normal lighting bulb with an LED? That's the question. That's the cause, because it's kind of a directed emission.
It is,
already.
Yeah, that's right.
And if you have a diode laser source, this is in addition to that also deflected with a resonator. So there is a resonator that emphasizes the laser beam and makes it very strong and very focused. That's also the same with the gas laser, same with the DPSS. So there's the resonator principle that faces the light beam. But in general, this is the difference between the DPSS and the diode. That the diode is semiconductor, and that's why it's more reliable, basically.
I hope that's right, Gareth. I hope that's answered your question, my friend. Okay, sorry, continue. I'm just going to quickly check on the lads. We've got two boys out in the background.
Yeah.
Got to check on them. Carry on.
Yeah, no problem. I will continue with the safety precautions you have to consider when opening a laser. Because one of the safety precautions I already mentioned: do not use blank tools, because the blank tools, they can reflect the laser beams. The same with rings, the same with watches. Do not use them when working at an open laser. I do it now because I know the risk and I know how to handle it, but normally it's very dangerous, because you can imagine what happens if you power that to full power and then it deflects. Even if I use white paper, or even if I use my palm, you can see how bright this is in the camera. You can't see it. You can see it now. You can see how bright this is, and this is the dangerous thing. That's why I say do not use any reflecting material when working on the laser. So I reduce the power again, and I show you something which is very specific with lasers. Now
I'll just put a bit more smoke in the room, just a tiny bit.
Yeah. What you can see now is here on top of the scanners. You see my palm, you see the laser beams. The scanners not deflect the full power, but there's always some portion of laser coming out at the top here. So if you bend over the laser and look inside, you get hit by these laser beams, and they are very dangerous. Depending on the laser systems, these are very, very dangerous parts. You can see that how much coming out of that. So this is very, very dangerous, and be careful when opening or when working on an open laser. This is the most dangerous part, and if accidents happen when working on lasers, when maintaining lasers, this is normally one of the cases why people get hit.
Do you think it's advisable to wear some form of glasses? Are there protective glasses that you can wear?
Yes, there are, but the problem is that we have RGB laser systems here, RGB white light laser systems. So we cover a very broad range of wavelength. And the protective glasses that are available normally only cover certain wavelength ranges.
Right.
So there is two different types of glasses you can have. You have, on the one hand, you have the protection glasses, and you have the alignment glasses. And there is a difference, because the alignment glasses can be used for alignment, so you still see some portion of laser through it. Whereas the protection glasses, they block it completely.
Right.
So if you have an RGB protection glasses on, you cannot see anything. You can use a brick wall or something like that.
Okay,
the same effect.
22,
So it's a bit of a tricky part. So normally, just reduce the power.
Yeah.
Be aware of the dangers, and nothing happens. In fact, I don't know of any customer that has any accident with any of our lasers. So I don't know of any. But this can happen, and this is where I say, okay, this is the dangerous part, be careful, and that's it.
Okay, cool, fantastic.
Yeah, and of course, common sense, don't touch the electronic part.
Don't put your hands in it.
Yeah,
exactly.
No, just try to avoid
Don't drink coffee over the top, not a good idea.
Yeah.
Okay,
so I got a question here. The regulations regarding lasers is just for lasers above 1 watt. Question from Kalle Christiansen. In general, the regulations are for all the lasers. There's different laser classes out there, and some of them are considered safe, some of them not. So there is laser class 1, laser class 1M. These laser classes are considered absolutely safe if certain precautions are respected. Most of the industrial laser applications are class 1. So welding lasers, cutting lasers are laser class 1. So people may question themselves, hey, why can a laser with, let's say, many kilowatt power can be considered absolutely safe? This is due to the laser being encapsulated. So it's kind of a room with a lot of locks and safety systems, so people cannot enter the room and the laser being on.
Right, got
so the whole room is considered the laser system, and
is that
therefore
like for
it's
cutting and things like
for
that?
cutting, for welding, and this is also infrared lasers, ultraviolet lasers, and all that stuff. So also laser beams you cannot see, which are extremely dangerous because you just get hit and you cannot see it.
Right.
That's a very dangerous
situation. Do you think that's what the government do with us? Boom, boom, boom.
You never know. You never know.
They get us with these like laser beams you can't see. Like, we'll get that guy on the street. Dong! He goes home and he's dead. You know.
Yeah. Pretty much.
Like, why did my arm just get sliced off there for no reason?
Yeah, but you're laughing, but there is already military is already using lasers for different applications. So I read an article about 1 year ago where they're using high-powered visible lasers to blind, to just shock blind opponents.
Wow.
Which in case works, of course. They became so small, the laser, and so powerful that it's simply be done.
That's crazy, isn't it?
But just getting back to the class 1 laser, which is not dangerous at all. There's class 1M, which is a different situation. Then we have class 1C, which is new since 2014. It's a new laser class which mainly applies for cosmetic lasers, which is a certain kind of class. Then we have laser class 2. Which is considered to be safe if you don't stare into the beam. Right. If you don't open your eyes and you keep on staring.
Like garden lasers.
Yeah, these ones are considered safe as well.
Yeah.
There is most of the garden lasers are class 2 if they're done properly. There's many out there which are not safe, which I checked myself, which are not safe. Ours are checked, ours are safe and approved, but this is a different thing. So there is garden lasers class 2, which are safe to use outside, safe to use in private rooms, safe to use in gardens. Then there is class 2M, which applies to lasers that are split up to a certain angle and then have a certain power levels under certain circumstances. So this is also considered safe. And then we have class 3R, which is which derive
a lot
from
of classes.
which derive from a general class 3, which has certain requirements in terms of safety. Class 3R is not that restrictive. You don't have to have the key switch. You don't have to have the interlock connector.
Right.
And it's up to 5 milliwatts. So class 2 is 1 milliwatt. Class 3R is between 1 and 5 milliwatt. And then between 5 milliwatt and 500 milliwatt, it's class 3B. Class 3B already requires the interlock connector and the key switch, but it's not considered to be that dangerous that it can cause fire, explosions, and all that stuff. Which is then everything else that is not under the other classes is considered class 4.
Right.
And class 4 lays everything above 500 milliwatt under certain circumstances, other power levels. This is also considered to be dangerous, very dangerous, because it can cause fire, explosions, and something like that. People may ask themselves, why explosions on stage? But it's pretty simple. If you've got a gas cartouche, for example, from a flame jet, and you have it on stage, and you have a very high power laser, and you put a single beam on that cartouche, which is painted black because nobody should see it.
Right, doof. Yeah.
Doof, you have the explosion. So there is cases where lasers can cause explosions even on stages. Right. So that's why just be careful. But it's in general, it's no problem. I haven't heard of any of these cases in the past, so it's pretty simple.
This is all interesting stuff, by the way, ladies and gentlemen. And if you've just joined us, welcome. We've got Norbert here from Laserworld, the MD from Laserworld. He's come. You're actually on holiday, aren't you? But
yes,
he's come along and he's doing his thing here. We've got a few lasers, and we're hopefully going to give you a lot of insight into the do's and don'ts, the best lasers to buy, what you should buy, what you shouldn't buy, and very quickly as well. At Laserworld, what is the cheapest laser someone can buy? And as I'm sure people would like to know, what's the most expensive that they could buy?
Yeah, the cheapest laser you can buy is, of course, some of these, consumer level garden lasers, which is about, let's say about €30 at the moment. I think there is some sale, and it goes up. It goes up to, let's say, €500,000. You can spend €500,000 if you like to.
€500,000 for a laser. All right,
that's all. But that's not the sort of lasers most people use.
No, I know. But all right, I'm sure there's people thinking now, what is it? What is your €500,000 laser? What's the power?
It depends. Normally these kind of lasers are built to the requirements of the customer.
Okay.
So
right.
Some customer require very very high powers in red, for example, because they want to do some country flags, which is very difficult. As I explained previously, red color, to make high power red color is very difficult to do. Right. That's why this becomes quickly expensive. There's also other laser source types, for example, coherent OPSL sources, which are very expensive. And if you want to have high power with these OPSL sources, the system quickly becomes very expensive. But these kind of applications are very special. There is some customers in the world out there that buy such systems from time to time, but the applications are very specific and more, it's normally all outdoors. It's all long throw, long distance projections, and there's completely different requirements than for a nightclub or a mobile DJ laser.
Yeah, of course. Okay.
So also the whole technology inside changes. So there is no combination with the dichroic filters anymore to that extent. There's different kinds of combinations. There's different layers. You have different layers in the system where the optical combination is done, and it's very very complicated. As soon as it comes to very high powers, very high quality systems.
That's why they're €500,000.
Yes, exactly.
Okay, all right.
So I got a question here from Martin Muller. He just tuned in and asked if there's a Pangolin FP4 controller, and if we use the FP4 and if we like it. Yeah. And yes, we of course use the FP4. We provide the most common software solutions. If you want to have an FP4 controller within your lasers, of course we have systems. We can add them as upgrades. For example, especially the more professional Tom 4 and Tom 7 units, so the bigger brother of those, which are completely built in Germany with RTI modules already inside. Also the RTI units, they're all available with the FP4 as option, so you can decide when you buy the unit if you want to have it or not. It's okay. Of course, it adds additional costs. FP4 is not cheap, so at least I think about 800 euro on top for the FB4 controller inside.
You can also upgrade the motors as well, can't you?
Yes, you can upgrade the
Is
scanners.
that in the TARM scanners, in the TARM, or
Yeah, you can upgrade them to faster scanners to be able to do better graphics. I think that's a good thing. We should have a look at the graphics, the different graphics option. But you can have different upgrades for the lasers. FB4 is one of them, but you can also use the Shonet interface, for example, which is less pricey, but also has the network access, because many people want to have network access for the control, because they don't want to do the old type ILDA cable anymore, the long ILDA cables, which are really, really tough to handle, because especially if you have the breakdown and this cable hooks into other cables and you want to get it down from the truss, everything is mixed up. You have a lot of cables mixed up together, so people want to do the network cable control, and that's why there's different solutions in the market. Basically all the software suppliers nowadays have network control options. For example, the LaserGraph DSP does it for many years already. It has always been the network control. We have the FB4 from Pangolin just recently being released, and then we have the Shonet interface, the Laserworld Shonet interface that comes with a show editor or can be bought separately. So the whole thing moves towards network.
Okay. Another question as well that I think people are probably thinking about, or may think in the future. Let's imagine there are people out there that have got £1,000, €1,000, and they want to buy one or two lasers. What would you recommend?
It always depends on what you want to do. So,
well, let's say, a general kind of show. For example, me. Road show. I do weddings, 18th, 21st. What would you recommend? Something for ILDA, something just DMX, ILDA and DMX, or maybe just sound to light. What would you recommend?
Yeah, so there is the basic option. Basically, what's most suitable for DJs is from my opinion, it's the EF 500 RGB key text. Key text. There's a keyboard coming with it, so you can just write simple text. You can save it to the laser, and you can call it later on by DMX automatically or something like that. And you also have built-in patterns, so you can just use it as a normal DMX laser. You've got a full color lasers, so it has white light, and it has TTL modulated sources inside, so you have many different colors you can show. And you can use DMX, you can use automatic mode, you can use sound to light mode, and you can use an infrared remote control with it. So there's all the different options that a mobile DJ normally needs and uses, because many of you don't want to use computers, which is of course. I understand that you don't want to have the additional computer to do that. So this is one of the options, and it's
I hope
not
that's been
expensive.
a good question answered, actually.
Then if you want to go for a system that can do more, can be used more professionally with computers, so you can project logos, for example, or text. The CS1000 is a good entry level system. It's basic, the features are basic, also the scanning is basic, you can do text, you can do logos. It can be flickering if it becomes too complex. But of course there's steps up. You can go with the Pro Line series, which is a bit more expensive, but not much. So we're about €500, something like that. And it's got additional effects with it. So you've got diffraction gratings, you've got 3D effects, something like that. So there is all the different types of effects built in there, and then you can go up with power. So if you need more power, you go for the diode series, for example. So more power. You have two of the diode series units.
DS 1800, which I take, well, not to every gig. I take if I for example, 18th birthday party or to festivals, and even the 1800s are very bright. Very, very bright.
I use them in a big halls also, so they're sufficient for many applications, especially for DJs, mobile DJs. Normally this is something really, really good. But there's of course more power. If you need more power, we've got the DS3300 RGB, for example. This one is even higher power, so 3.3 watt full diode system. So we have also technology change now. Diode series has full diode equipment. So what we talked about earlier, the different technologies. With the diode series, we have this technology switch to the more professional technology as well.
Right, cool.
So there's these questions coming in.
I'm going to check on the lads again, because
yes,
like I said, my little boy and Norbert's little boy are playing. I just got to check on them.
So we got a question: can you explain the difference between half angle and full angle laser beam? And this is a very good question, because you know, the laser beam has widens up over the distance. So if you have the laser beam, even though it's very, very narrow, if you shoot it over a distance, it widens up. So this widening of the beam is the so-called divergence, and every laser system has specified the beam specifications in the brochures, and it also specifies the beam divergence. Besides the beam diameter, there is the beam divergence, and the divergence is very important, because it's the far away you look at the laser beam, the more important becomes the divergence. There is a calculation about that. I think I put it online on our website, so you can have a look at. I think it's technical explanation somewhere where it's explained how this works and how the diameter and the divergence go together. But this is on the website. I just want to go more into the specifications in the brochures. So there is the option to do a half angle or a full angle divergence specifications. There is a huge difference. Half angle is only half of the actual true divergence. So by specifying half angle, you can imagine the brightness of the laser beam is distributed like a Gaussian curve, more or less Gaussian curve, like this. So in the center it's very bright, and it becomes dimmer on the outer edges. So if you specify the full from the low to up to the low, if you specify this part, even though the edges are very dim, even if you include them, then it's full angle. If you just take half of it and say, okay, the dim parts I don't want to consider, I just want to have the bright part inside, then it's half angle. And you can imagine, if it's only half, it appears to be much more valuable, but in the end it isn't, because you just have the same thing, but it's just made look much better, much more valuable, but it isn't in the end. So be careful. If it's about half angle or full angle divergence, you can ask the vendor and say, okay, is that half angle or is it full angle? And he needs to specify how he really gets these values. Be careful. There's many people out there that try to play with these values, and that's important to consider. So there's another question. Kali Christiansen asks, to make a text on the CS1000, what do I need and what is the cost? Yeah, basically to do text on the CS1000, you of course require a solution that allows you to create the text. DMX is not suitable to do that. DMX is not suitable to do anything creative in form of making the laser do something. DMX is only a trigger signal. So DMX is not suitable to do text. You need computer control. You need a computer software to do the text with a CS1000 or any other laser, more or less. There's the key text lasers, but for normal lasers you need software with it. There's different types of using software to create texts. Normally, the normal way is just having a direct connection between the computer and the laser, and you do the text on the software and the laser directly projects it. A solution for that would be the Laserworld Show Editor, which is the most budget solution. It's about, I think at the moment it's traded €280, something like that, including the network interface.
What we'll do is when this stream finishes, I'll put excuse me, not only a hyperlink to Laserworld, but we'll also put a link to the show editor because I think it's quite important.
Yeah, this software is has all the features you normally need within. There's a live feature, there's timeline feature, and you can do the text live, or you can save it and call it later on. But there's also in this interface, there's also an SD card built in, and you can remove it and you can put your own text on it. So you can create the text with a computer and you save it on the SD card, and then later on you can just recall it by DMX or automatically. So this gives you additional freedom, especially for mobile DJs. So you can prepare the text on your computer at home.
Yeah.
You put them on the SD card, and you just have the interface on top of your laser, and you can recall it with DMX, and you can even modify it. You can return it, do colors, different colors, and something like that with DMX. But let's get back to the difference between ILDA and DMX. So the CS1000 question was a good link to this, because there is a huge difference between DMX and ILDA. Many of you know how DMX works. DMX has 512 channels, and each of these channels can have values between 0 and 254. So you're limited in the way of values you can give. But DMX is just meant as a trigger signal. So it just gives an information that something
on and off, isn't it?
Yeah, it just gives information that something should happen. And it just gives the information, this should happen, this should happen, this should happen. But it doesn't specify what actually should happen, because this is all built in the DMX unit. So even you have like a moving light, or you have an LED power, or whatever you have, every DMX unit has a built-in controller, a built-in chip that says if there is a signal coming in on channel, let's say 2 with value 210, then do this. If there's a different value coming in, do that. And that's why the signal itself, DMX signal, is super stupid, basically. It doesn't do anything creative to the unit, but it triggers the creativity of the unit, the built-in features. Whereas the ILDA signal, which is the big connector here, it transmits all the information, the creativity, directly to the laser. So the single pins in this cable, which is a 25 cable, each pin is connected to a certain feature in here. So one pin, for example, controls the intensity of the green diode, the other one the red diode. Some control the position of the X and Y axis scanners. So the signal is very, very dense. So we have a very, very high frequency signal in there. That's why we have the different lines, the 25 lines in here. And even if we have a network controller, something like that, it does more or less the same. We get the network signal in here, and it transforms the network signal to the analog signal and gets it in. We can build this one in here and just have the network controller, but in the end, the laser diodes need to be controlled somehow. So this one gets to a transforms the thing to the very basic ILDA signal. So the intelligence comes from the computer. It's not in the unit. The unit itself, it's stupid. So that's basically the difference between DMX and ILDA. And there's one other very important difference that needs to be considered. You all know that if you have a DMX unit, you can address it. So you can say this unit, this moving light has address 1, 2, 3, and you can address them individually. And you just daisy chain the DMX. If you daisy chain ILDA, which is possible, all the units do the same thing, because the signal is specified per interface, per hardware interface. So for each laser you want to do individual things, you need individual interfaces, which is no problem. The software can handle it. So you just put more interfaces, and then you can have the lasers do individual things. But this comes from the different type of signal. It's the high density signal. It's not just a trigger signal, which can be easily, also transmitted over long distances with DMX cable. This one is a high density signal, so it's completely different.
Okay. We're back on. Apparently we lost the live feed here, but we're back on, so we're all good.
Good, okay. Then we have another question. Is there a reason why does Laserworld give total laser power and guaranteed laser power for the laser devices? Yeah, of course, there is a reason, because the laser power is not always specified exactly, especially depending on the product level. So the higher professional the laser systems are, the more specific you can adjust the power levels. Okay. So we always give a guaranteed power level. So this guaranteed power level you can rely on. So if there's in the brochure it says guaranteed power, this is the guaranteed power you get.
So if the minimum you'll get.
Yeah, even if there's, there can be circumstances, you drop it, or the parcel service drops it and there's damage, and you measure it and it's not at that power level. You can return it, because it's a service case, of course. So what's guaranteed is guaranteed. Yeah. And that's basically the thing. So that's an important thing, because some people ask, there were irritations in the past because people measured wrong and something like that, and we had irritations. But normally it's all as specified, and people can rely on that. Good. That's an important thing. Okay, good.
Do you think it's worth someone insuring the laser? So, for example, I presume you do 12 months warranty, don't you?
It depends, yeah. Normally, yeah, but even longer. Okay. Normally, there's longer warranty. It's stated in the terms and conditions.
Yeah. So I suppose it's like buying anything. If you buy something cheap, it's probably not worth it. If you buy something that's going to be expensive, it's in your best interest to insure it once the the warranty is over. Yeah.
Yeah, that's. That normally we don't handle that normally. Right. That's normally handled by the purchaser. Normally, if you have kind of a leasing company that handles your stuff. Many people lease products, but we don't do that on our hand, because we cannot give that good conditions as the your individual bank can do. So this is normally handled by the leasing companies. I know of some people that do it, and it works very well. So if there's any documents needed from our end, we of course can provide that. Okay,
right. Mark has just said this guy certainly knows what he's talking about. He should do.
Yeah, most probably.
Yeah.
There might be some things I don't know, and this is okay, and you can ask them and try to find them out, which is good.
Mr. Laser, Mr. Laser himself.
Please ask. Yeah. Please ask. Is there any further questions?
I think we're all right. Is there? I mean, you've got like the garden laser over there, or one of them. Do you want to maybe show one of those?
I think we do that. We do that later, and first. We show some alignment on the DS3300.
Yeah, okay.
Because I have a DS3300 which is misaligned here. It came out of convergence. So we have red, green and blue not matched anymore.
Okay.
And with a DS3300, like with the other DS, it's pretty simple to handle that.
Okay, shall I move this out of the way?
Yeah, just get that out of the way.
Right.
And... I power that one up.
Okay, put a bit more smoke in here as well.
Yeah, you can.
Yeah, my last joint failed, so I'm going to light another one.
Yeah, the interlock connector. Wow, that's a bright one. So you can even see the reflection now. You can see it from the wall. That's a 3.3 watt. So a powerful one, a bright one. But you can also see if I turn down the powers. I need to do that here in the software.
I wonder what it's like if I just turn. I'm just going to turn the light off. Is that can people say, is that actually any better? Is that okay?
I think it's okay. I think it's okay.
I reckon that's going to be okay actually.
I'm getting down power. We got the misalignment in red and green, so I need to do a shape that shows us what's actually happening, which is pretty simple here. I just show you. I'm doing that with a show editor, so we can all have a closer look.
Do you think that's a bit too dark now?
No, it's okay. It's okay.
Yeah.
So it's pretty simple. I just say I make a new figure, and I have white as color, and I just draw a rectangle.
No, that's actually good.
Buff,
yeah.
And now we have the rectangle on. It's super simple.
Yeah.
Here you can see it. Now it's pretty bright. I reduce power so we can see it better. Now there was a mistake. That was my mistake. I just accidentally clicked somewhere. Now we have it back on. I'm getting down power.
Okay, people watching the stream, is this okay with the light off, or do you want me to put the light back on? If you could just let us know.
So what you can see now, can you see it? I'm not sure if you can see it. It's still, I think it's still too bright. People here on the Laserworld stream, they can see it. Probably can close up a bit, Jonathan. You can see it's misaligned. So this line here, the lower line is blue, and the upper line is green. So we've got a misalignment here, and they don't match up in white, which they should.
Okay, Leon, thank you. EMP Gold saying light on.
Yeah,
okay.
Probably. Put the light on again. I think it's better for the cameras. They can catch it better.
Right, lights going on. There you go.
So here we go. So what we do now for the DS, I just switch it off so I can show you for the camera. For the DS, I open this little lid here in front, and you can see there is inside there. So you have a torch.
Yeah, I'm just going to get one now.
Yeah,
we'll get torch.
we have alignment screws, so we don't have to open the whole unit, but we can align it here from the front, which is super simple. And what we need is just an Allen key, and then we can do the alignment here. It's always good to make a certain static test pattern. For example, what we now use is the just a rectangle, which is fine for what we do for the alignment. But you can also use a normal test pattern, normal ILDA test pattern. There's different test patterns available. But
here we go.
So here torch. We go. Torch. We look at the torch. Look here. It's too bright now. Okay, you can see there's different screws in here, and this is the adjustment for the mounts of the dichroic filters, and this is where we do the adjustment now. I know that the difference between the individual diodes in here, we have the green one, then we have the red one, and we have the blue one as last one. So this is what I found out before when I lit up the laser and I looked in here from the side, and I saw which one I have to adjust. So now when I power it on again, I can see that I don't have to touch the right one, but just the left one, and I just give it a try. Which one of these screws are relevant for me now? I just have a look. I check the upper one. Can you see it? Yeah, you can see it. I just turn it, slightly turn it. Just slightly turn it.
Yeah, that's moving.
It's moving. Yeah, it's moving. And you see, it's not moving up and down, it's diagonally moving. That's important to understand. So if you turn this one, you always have to turn the other one to come back in this direction. So just giving it a try here. You see it goes up and down. It's
important to get them aligned for correct color mixing, isn't it?
Exactly. That's it. Otherwise it doesn't shine white. It just has purple and green together. Mm-hmm. Now it's good from the top, but we have to get left and right more. So I need the other screw as well. Now it gets down a bit again, but it's in the right shape. So I need to use the other screw. So it's kind of a bit of a try and error if you're not used to that. Mm-hmm. It's a bit of a try and error. But now we're fine. So what you can see now, it's a really clean blue-green line. It's nearly white, nearly showing white. Good. But now we add red, and it's very white.
Yeah, that is really bright.
That is really bright. Yeah. Crikey. So you cannot see that properly at the camera because the camera is not made for doing such high power record.
And how much are the DS 3300 RGB?
I don't have the actual prices in mind. I'm afraid, but I think it's about 2000. I can check.
Right.
Check on the website. Check on the website. And if you're a commercial customer, you can also register on the website and probably get some additional discounts or different conditions. And you can also download further material down there for dealers and distribution partners and commercial customers. There is more material online.
Okay.
So if you're a commercial customer, there's different options available.
Okay. Cool.
So there's another question from Martin Moore. Do you guys have a personal favorite laser? Which is a good question. What's your favorite laser?
Well, I think it has to be the ones I got, the DS 1800 RGBs. I like.
You're happy with them?
And again, yeah, because I have two. You know, you can just set the one up, and you get a good show.
Yeah.
But you have the two, and you do like a mirror image.
Yeah.
Then you know it adds to the whole ambience of the room. You know, you get that kind of sort of wave effect, and they're all moving as a mirror image, and it just adds another dimension to a complete light show.
Yeah.
So what I will try and do as well is when we finish this stream, a friend of mine did some quite good footage from Lake Fest, which was a festival we did last year. I have those two lasers set up, and it's stunning. It's absolutely amazing, you know. And you get a lot of smoke in a room and a laser light, and it's far superior to any LED light because it just cuts through that, you know, the darkness. So it's great, fantastic.
Yeah. My favorite laser is the RTI Neo 1.
Right.
Because the Neo 1 that has just been released at the Pro Light and Sound. It's
modular. The modular one, yes.
Exactly. It's a hexagonal shape.
Yeah.
And you can adjust them to each other. So you can build a circle, or you can build a line, or you can make, you know, just a huge laser array out of it. But it has full, you know, the full X and Y scanning features, and it has the built-in SD card, and you know, you can trigger them directly, so it all has the built-in control features and something like that.
But they're
like that pretty much.
4,000 euros, aren't they?
No, not that much.
Right, okay.
But they're meant, you know, they're meant for big stages. They're meant for rental companies, so you just buy
slightly
that.
more high end there.
Yeah, but you will see them more and more out there.
Yeah, sure.
On the big stages, for example, big festivals you attend.
Yeah.
There's many rental companies just getting them now because they have the RTI Neo 6, which is the beam bars, you know, with the X and Y scanning. Are all over the place now already, and there's huge demand. But the Neo 1 is even more than that, because you can make different shapes. It's similar features but different shapes, and you can scale it to huge stages, and it's so powerful. It's 4-watt power RGB, so it's really powerful even for outdoors. And I like lasers when they really blow outdoors. That's what I like, you know. It's not interior use, you know, internal use in the house, in you know, in a venue. It's also cool, but outdoors, that's what the laser really blows.
Fantastic.
Yeah. Good. Okay, so you mentioned one important thing, which is, I think, very important to mobile DJs, but other users as well, is how to set up the laser.
Yeah,
because what you mentioned is that you have your two lasers. If you use two lasers, you have them left and right at the stage and make them x-axis mirrored, so they just not move like this.
Yeah.
But move like this, just mirror image, which is one of the very, very common uses of lasers and how you set up lasers. The most common laser setup is basically a 3 laser setup. So we've got one center laser doing the center image, and 2 ones that are x-axis mirrored left and right. This is a very common setup. And this is what I also recommend, because you can then fill a whole room, because you can scale it. Even if you have a small stage, you just put them more side by side, and if you have a wide stage, you can just move them aside, but you still can cover the center. Because if you only have so if you only have 2, then they're too far away. But with the center one, you can cover the middle. So you can scale it pretty easily to nearly any size of stage. So that's what I recommend. And there's always the question, how do you mount a laser properly? Because there was a question by one person saying, hey, can I mount can I mount it on top of my speakers? Can I just put it on top of the speakers?
Not a good idea.
Yeah, it's not a good idea, because what we learned previously is that they can misalign if there's shock or vibration.
Yeah, and vibration. So the speaker, however good, is going to vibrate some way, and it's just like you wouldn't do it. You know, it's like thinking about sticking something on a driving car. The car's going to be moving. So, if anything, you know, if you're going to invest a lot of money, you've got to make sure that your investment is secure, and you wouldn't put it on anything that's going to move.
Yeah.
End of.
Yeah, exactly. But there's the other question always: how do you do it then? Because there's different options. Of course, if you've got a truss, then it's no problem at all. There's no issue.
Okay.
If you've got a truss, there is no issue at all. You just clamp it to the truss and hang it down there, and everything is safe.
Yeah.
So this is. But in many cases, you don't have the option, because, for example, you don't have a truss because you cannot hang it, or you just have, let's say, a small lighting rig, or the rig is on different positions where
or a T-bar or something like that.
T-bar or something like that. So what I like personally is just have simple tripods that you can use, that can go up to a certain height, and where you can easily mount the lasers. As the lasers became much smaller in the past years and much lighter, it's easier to use let's say easy handling tripods. This tripod I have here, it's a Manfrotto one.
Yeah, it's very good.
It's only about 2.2 kilo or something like that. So very lightweight, and it can go up to the relevant height with a laser. What I did here, just to show you, it's also kind of a suspension. If you drop it, for example, the laser, if you see that, I open it now and it falls down. It's kind of suspended, so it doesn't bump. So that's kind of a cool tripod. And what I use here is a super clamp, Manfrotto super clamp. It's just on top here. It easily goes on top, and I can fix it. What I did here, I just turned the mounting bracket upside down and put it on here.
Yeah.
Just attach it firmly, and that's it. This is nearly too heavy, this laser, for this kind of tripod. You always have to respect your local regulations regarding that.
Yeah.
But this is a simple way of using the laser, of mounting the laser, and you of course have to save it and something like that, but this is general things. But I've seen many people, you know, dealing with kind of, you know, strange structures, like having structures like this and hanging the laser in this structure, kind of, you know, huge constructions just for hanging the laser from the top. This is not necessary with our lasers. Normally you can just turn the mounting bracket upside down and stand the laser. There's also other tripods, wind-up tripods, which are more professional, that have a spigot system, so you can just attach the spigot. I don't have one here. Just put it on top here, you screw it to here, and then you just put it to the tripod, and that's it.
Yeah.
So this is the easiest way of mounting lasers, especially if you use the mobile.
Right.
Because normally, if you do a mobile show, you don't have much time to set up. So everything must be quickly, and that's the quick and easy solution I normally use.
Got you. Okay. Right, we're getting on to nearly 2 hours now, so I think if we go for another quarter of an hour or so.
Yeah.
Yeah.
I'm fine with that.
Okay.
Do we have any further questions?
Any more questions for anyone? Let's have a look. New setup for Lake Fest. Yes. Eric saw them in Frankfurt. Yeah, the Tama 4. Let's have a look. Are they sold in the USA? So, a question from Ian P. Gould. I mean, I can sort of answer that. America has far more legislations with lasers. It's a lot more technical. It's not really easy. So we'll get into that.
Yeah, but it's no problem. You can just get the lasers. You can buy them. It's no problem. We ship to the US. So if there's any requirements, you can also ask us. Laserworld.us is the US website. There's also contact details. So if you've got any specific questions for the US, you can call, and our US guys will consult you regarding that.
In other words, you're okay.
It's all okay. Yeah.
In other words, I'll shut up.
Good. So any further questions? I just checked because I had questions previously.
Yeah.
And there was one question of a user that uses lasers with big mirrors in. He wrote, my laser has super big mirrors in it, but other lasers have small mirrors. Can I exchange the big mirrors with smaller ones? So just to answer this question, these big mirrors, they're from stepper motors. So the very affordable laser systems, low-end laser systems, that are mainly used for audio, for beam shows. You know, see the beams in the room with a smoke, but they're not used for text projection or anything like that, but just for the effects. They sometimes are equipped with stepper motors, and these stepper motors are just rather slow motors, and they deflect the beam with rather big mirrors. And the idea behind these is just to have a very affordable laser system, to just have the effect, but they're not meant for more. So it's not possible to exchange these mirrors, because it would mean to exchange the complete system, and for that money you can buy a completely new, much more professional system. So it doesn't make sense at all. Just sell the unit and get a more professional one.
Okay, cool.
Yeah,
cool.
Yeah, that's a good question. I've got one here. I've got a couple of these garden lasers to extend my DJ lighting rig and also provide additional effects for outdoor garden parties. The effect is so different to the other lasers I have. How is this created? Are there many small lasers inside? This is a good question, because most of you know these garden lasers, which do these kind of effects. I'm not sure. We can just power one up here. I think we have one.
Is it a refraction mirror, or is it like a prism?
No, none of that.
Right.
It's not a mirror in this case. I just get that one out.
Okay. Right, he's going to plug one in right now. So.
Just getting that one going. Whoop.
See, we're very technical here. We've got everything.
Yeah. So which one I can unplug?
GS2. So this is the GS200R.
Yeah. GS200 RG.
RG. Red green.
Red green. We turn the camera so you can see it. So this is basically the effect, classical star effect laser, and this effect is created with a so-called diffraction grating, and this is created through transmission. So there is one laser beam getting in, and it's like you probably learned at physics at school. It's kind of a bending of light. So you have a grating where you shoot the light through, and it bends on every single hole it hits. So it's that's why it's also very, very bright in the middle, and it's getting less bright on the outer part. So in here is two laser sources. It's a green source and a red source, and these two sources shoot through this diffraction grating. In fact, these are two diffraction gratings, because it can rotate as well, and that's where the effect comes from.
Okay, Eric's just asked, how far do they go? So in other words, what's the sort of distance that a laser like this could say, give a relatively good image without losing any intensity?
It depends on the product. So what we offer is two different types of products. We offer products on a consumer level, which is a laser class 2. That means it's considered safe. So also from John Doe using it somewhere in the garden, having no clue at all. And then we also offer them as laser class 3R, which is 5 times brighter.
Right, okay.
So there is a difference.
With garden lasers as well?
With garden lasers.
Right, okay.
Which are mainly aimed for mobile DJs that want to use it in a more professional way.
Yeah.
illuminating garden parties outside, illuminating the trees, or illuminating even the dance floor in their venue. There's different options where you can use them. So we offer these different types, so not only the class 2 but also the more professional ones. The class 2 ones basically are well suitable for illuminating a whole house, house wall, front of house. That's all fine for them. If it's dark outside, that's basically what they're used for. The class 3R ones, they go much farther. So what I tested was just having a whole forest was about 100 meters away, and it was well visible on the forest side. So it goes much farther. So it depends on what product you decide to go for. I personally love the stronger ones, of course.
I mean, very quickly as well, if you are a mobile DJ and you're considering getting some lasers and you do a lot of outside parties, what you've got to remember is that when the client books you and they book you as a DJ, you will give your fee, you'll give your price. But then, I mean, theoretically, you could say to them, well, I can supply lasers to light the outside of the marquee, maybe to light the trees, and you can add additional fees to that. So, for example, you could add another 200 or 300 euros just by taking 2 or 3 lasers.
I don't know if it's that much you can do. I think it depends on the area you're from. But it depends also on the laser. We have RGB ones as well, so they make blue as well, which is nice. And maybe there is a question, why can't you do that in white?
Right.
Because people want to have it white star would be nice, and so on.
Why can't you have it in white?
You can,
but
with a different technology. So this technology, with having the diffraction grating, just showing that one here. With diffraction grating, the way of doing this means that you shoot one single beam and then you have the optical bending. And this is the same thing as the question we had previously.
An idea of size. There's the size. There's a CD, and that'll give you an idea of size.
We talked about the prism previously, and this is basically more or less the same effect. So if we shoot in a white beam, it will not split up wide. There will be only one white beam in the middle, and on the others they will split up in different angles due to the different wavelength, because it's always multitude of the wavelength that we have in the split up. So with this technology it's not possible, but there is a different technology we just developed. So this is the new white star effect, the GS400 RGB white star. This is not available yet, but it will be in about 3 weeks. It will be available, and this is a white starry sky effect.
Nice.
And it's even not like this, because the effect you have here is very, very symmetrical. But the white star effect is not symmetrical. So it's like a real starry sky effect. So you don't have this symmetrical thing, but it looks like a real starry sky, and that's an interesting thing.
Great.
Well, that's an interesting thing.
Anyone watching my stream, sorry, it did go off very briefly, but we're back on now, and we've got a whole bunch more watchers. So nice one. Thank you very much. All good. We're back. We're back.
Good. Great. That's it. So the effects we have here, this can also be achieved with normal lasers. That's what I wanted to show. So now we have the DR3300 RGB backup and running back aligned. And now what we're gonna do is we bring in this mirror.
Aha!
This mirror, that's a special mirror. It's not only a normal deflection mirror, but if you look from the side, you can see it, Jonathan. People cannot see it that way. You can see there is a multi deflection in there. Yeah. And now what I do is I shoot a single beam with the laser.
So should we turn this one off? I'll put that one over there. Face that one that way.
Yeah. Okay.
Right, bear with this. It's all technical here. There you go.
This is all technical. I just switched off the scan safety, so the beam block safety switched off now. Otherwise, we wouldn't be able to do a single beam. And now this is just the single white beam. And what you can see now is the deflection.
That is
and
amazing.
You can see how the colors split up. So we have the deflection of the white beam, and then the colors split up.
That is amazing.
And this is a. And now you can see it at the ceiling. We just have a look at the ceiling.
That is pretty cool. Yeah.
So this is how this mirror works. And this is the same principle as with the garden lasers, but it's meant for more professional use. So you can imagine if you have several of these bounce mirrors in a nightclub, the effect is great. You can also add more haze and fog, and then you can also see the beams in midair.
What would happen if you, again, I like asking daft questions. If you had another mirror and you used the one mirror and then you bounced from these beams onto a second mirror, what image would you get?
You would get a similar image, but with many more of these. But the problem is that you need to be very close, otherwise it splits up very quickly. You see, the deflection angle is pretty big, so you would need to be that close, and the effect wouldn't be that nice anymore because it's not that structured anymore. Yeah,
and it wouldn't be as bright.
No.
Right. Okay. Wow, that's good. And I saw that earlier on. To me, it just looked like a normal mirror.
Yeah, but the good thing about these mirrors, there's a similar other effects mirrors. For example, you can do that in a dotted line effect as well. Yeah. The good thing about this is they are relatively cheap. So you can buy them relatively easy, and you can extend the effect your laser creates. Right. So you can put them on the opposite side of the room, and you can just shoot across the room and balance the effect back. So you can fill the whole room with this effect without having to have additional lasers.
Got you.
So you have.
I like it.
For example, you have 4 of these. For example, another 2 bounce mirrors and 2 line mirrors, and then you can just shoot the different mirrors. Wow. This is really great effect.
It is,
and without having additional lasers.
Cost per laser? Sorry, per mirror.
I think about €60 or something like that. If you take more, then of course there's more discount possible.
Okay. All right. Cool.
So that's that's about this effect. So let's see if there's more comments.
Again, if you just joined us, I've got Norbert from Laserworld here, and this is the second video on my stream because I did somehow lose connection, but by all means please watch the video because it's pretty much been a lot of questions answered, and also Norbert has explained a great deal on what a laser does, what it's for, what you should do with it, what you shouldn't do with it. We've done alignment, we've done why you have plugs in the back, why have you got a key in the back, what does the DMX do, what does the Ilda do, why do you have this plug and why is it there, and just little questions. So by all means, if you've just joined us on this live stream, then go back and watch the entire stream if of course you are interested in lasers.
Yeah, which we hope.
We hope so. Back to you, Robert.
Okay, good. So if there are no further questions, I think we're pretty finished for today. I think.
Okay.
If there's any further questions, just post now.
Or having said that, if you want to, we're going to go over these videos, and you can always post them in the near future in a comment, and we will do our best. Or Norbert will do his best, of course, to answer them. Yeah,
probably we just do another session like this, and
sure.
Get more into more detailed questions, find more questions. I'll just have a look in my list because I collected some questions previously. There is a funny question I got, which is interesting, especially for the UK mobile DJs. One question was, who was the first with naming their product CS1000? Was it FBT or Laserworld? And I can just say Laserworld had the CS1000 RGB since 2011.
Right.
That's it.
Okay, there you go. So there's hopefully that is the question answered. Okay.
Good. Okay, so any further questions? I think
Let's have a look. Very interesting feed, guys. Thank you. Mark, thank you very much for your comment. And John Cousins, hello. Interesting video. Thank you very much. So, well, there you go, guys. Hopefully we'll be doing another live stream soon. Yep. But in the meantime, go with the video. We will be uploading some to YouTube as well. And all being well, these videos will be on Facebook. And I'll finish off with practice and enjoy. Thank you.
Practice and enjoy.
Thank you very much.
Thank you.